Welcome, math enthusiasts. In this video we're going to talk about completing the square. That's another method you can use to solve quadratics. So let's look at when it's good to use this method. So remember, your quadratic looks something like this: ax squared plus bx plus c equals 0. Sometimes it may not be easy to factor this. So you can use the completing the square. So when you don't have a perfect square, so I suggest you use this method when your a is 1. So it's gonna look something like this: ax squared plus 3x plus 25 equals 0. This may not be easy to factor, so it's better to use this method when it looks something like this. So let's look at 3 examples. In our first example, we're gonna have x squared plus 6x equals 7. So the way you do this completing the square method is by doing this. You take your coefficient of your x term. You have 6, you divide it by 2, that is 3, and then your 3 you square it, so that would be 3 squared equals 9, and that you have to add it to both sides. So x squared plus 6x plus 9 equals 7 plus 9, that's 16. Now this is a perfect square, so you can just do like this: x plus 3 squared equals 16. Now it looks like one of our root property methods that we can use. All we have to do is take the square root on both sides. So the left side becomes x plus 3, and the left side becomes positive or minus square root of 16. And the square root of 16, we can reduce it by taking the square root. So it'll be x plus 3 equals positive or minus 4. Square root of 16 is 4. Now we move the 3 to the other side. So we have x equals 4 minus 3, which is 1. So that's your first answer. Or x equals negative 4 minus 3, which is equal to negative 7. Negative 4 minus 3 is negative 7. So there you have your second solution. That completes the first exercise. Let's look at one more example. Your second example says that x squared plus 4x plus 1 equals 0. So first things first, we notice that this is on this side. We can leave it there, but I suggest you move it to the other side, because anyways we will not have to move it later on. So that will be my plus 1. I'm going to move it to the other side. That becomes negative 1. Okay, now we're going to do this in the middle to get the number that we need here and here. So we take 4, divide it by 2. Always divide it by 2. We get 2. So then 2 squared equals 4. So that's what, so this here goes here and here. So that would be x squared plus 4x plus 4 equals negative 1 plus 4. So remember, the left side is a perfect square, so we're going to do x plus 2 squared you're just factoring this, and then it will become negative 1 plus 4. That will become positive 3. Now we take the square root on both sides, so left side becomes x plus 2 and the right side becomes positive or minus square root of 3. Notice here square root of 3, you can leave it like that. You cannot take the square root and get an integer. Okay, so the final answer is going to be x equals, we move the 2 to the other side, it's going to be negative 2 plus or minus square root of 3. And there you have your two answers. Let's look at one more example. So exercise 3, x squared minus 2x minus y equals 0. Remember, we're going to move this to the other side, so we're going to be left with x squared minus 2x equals 5. We need to get a number here and here. How do we do it? We take that coefficient in the middle, negative 2, we divide it by 2. That's negative 1. Negative 1 squared, that's 1. So plus 1 plus 1. So, okay, so this is a perfect square. So all we have to do is going to be x minus 1. When we factor, it's going to get x minus 1 squared equals 6. Final step is to use the root property, the square root property. So we take the square root on both sides. Left side is going to be x minus 1 equals positive or minus square root of 6. Notice we cannot reduce this one, so we just leave it like that. So now what we have to do is move the negative 1 to the other side, so we do x equals 1 plus or minus square root of 6. And there you have two answers, 1 plus square root of 6 and 1 minus square root of 6. So this concludes our video. We learned how to use completing the square method whenever we have something that is not easily factored, and specifically when you don't have, and I suggest you use it when you don't have a coefficient on your x squared term. Otherwise, it's going to be completing the square is going to be a little more difficult. When you have coefficient on the x squared, I suggest you use completing the quadratic formula, and you have another video for it. Thank you very much. Don't forget to subscribe to my YouTube videos, please.